Newton's gravitational law. Newton's gravitational law states that any particle of matter in the universe attracts any other with a force varying directly as the product of the masses and inversely as the square of the distance between them. Here is the formula that you use in the section, and this is an example. So this will be mass 1, mass 2, this will be the radius that you substitute here, and this is a constant, and then you solve for your F. This section may also have graphs, and in this case you can see that force and the radius is inversely proportional to each other, and the force and the mass is directly proportional to each other. There are some factors that influence this gravitation law, and the first one is force and mass, and the second one is force and distance. Please take note of this because they could ask this in a multiple choice question. We will now practice some past paper examples like we always do. The first one, the planet Mars has an approximate mass and radius. Calculate the approximate magnitude of the gravitational acceleration on the surface of Mars. This is pretty straightforward. You have your formula and you just substitute everything. This is a constant that is given to you in your data sheet. This is your mass they've given. This is your radius they're given. And you just solve. The next one is a bit more complicated. A man on the surface of planet Y weighs half his weight compared to the weight on the surface of the Earth. The mass of planet Y is twice that of Earth. Calculate the radius of planet Y in terms of the radius of the Earth. Now, this is planet Y, this is the Earth. Take note of this. The mass of planet Y is twice that of the Earth, meaning that the Earth is half of planet Y. Thus, you put a half here. Now you just substitute your formula, taking note of the half. Now you're left with 4r squared equal x squared. You need to get these x by itself. You need to square root it, so you get your x by itself, and this becomes 2r. This is a fairly simple example. I want you to try it first before you look at the answer. Planet Y has a radius of 6 times 10 to the 5 meters. A 10 kg mass weighs 20 newtons on the surface of planet Y. Calculate the mass of planet Y. You have your formula. That's the first thing. You have your 20 newtons because they've given you that. You're solving for your mass because it says calculate the mass, but they do give you a 10 kg mass. Then they've given you the radius. Make this mass the subject of the formula and you solve. The next one. The satellite has a mass of 615 kgs and is in orbit around the Earth. If the Earth exerts a force of 5,000 newtons on the satellite to keep it in its orbit, calculate the height of the satellite's orbit above the surface of the Earth. Again, you need to do a formula. They've given you 5,000 here. They've given you the constant. That's your normal on your data sheet. They've given you 615 here. You get the mass of Earth on your data sheet as well, so you need to look. And this, now you're solving for your R. The height would be this minus the 6,38 times 10 to the 6. You get this from your data sheet and you get your answer.